Talk about two new laws. Yeah. Law of syllogism and the law of detachment. The law of syllogism and the law of detachment. I'm not sure where the names come from. Okay? It doesn't much matter to us. We just want to understand what these laws are about. And so today when we're done, hopefully we'll have a fair understanding of what the law of syllogism looks like and what the law of detachment looks like. I'm going to spend some time looking at it with you in symbols because I think the words can get really messy. And I'd like you to start learning to put the messy stuff into simple symbols so that it's easier to organize your thoughts, and then you can go back and put the words back in. Okay? And so we're going to practice that a little bit. Not a lot. We don't have a lot of time left, but we'll practice that a little bit. Anybody not finished copying this down? So, law of detachment, deductive reasoning, first of all. Deductive reasoning is making decisions or conclusions based on statements. Inductive reasoning is making conclusions based on patterns you observe. How many of you have a little brother or sister? Okay? Right from the get-go, they start using inductive reasoning. They're hanging out, they're following you around, you walk in your bedroom, you flip the switch, and the light comes on. Then you leave your bedroom, you flip the switch, and the light goes off. Then you go into the bathroom, you flip the switch, and the light comes on. You leave the bathroom, you flip the switch, the light goes off. You go in the living room, you flip the switch, the light comes on. You leave the living room, you flip the switch, the light goes off. What are they realizing? If I could reach that thing up on the wall and flip that, the light's going to come on and off, isn't it? And so as soon as they can reach it, what do they start doing? They start playing with that switch, don't they? That's inductive reasoning. They're seeing a pattern. They see you do it once, they don't think much of it, but when they see it over and over and over again, they start realizing, hey, that light's going to come on and off. I can control the light. I have power. If I could just reach that switch. And so they start climbing up on chairs and stools and luggages and anything they can to reach that switch, and then they start flipping it on and off because they want to see the light go on and off. Inductive reasoning. Okay? How many of you are deer hunters? Okay? November 12th, 8:05 a.m. This giant buck walks out into the field next to the house. November 13th, 8:05 a.m. This giant buck walks out in the field next to the house. I said 13th, right?
Yes.
November 14th, 8:05 a.m. This giant buck walks out into the field next to the house. Where do you think you're going to be sitting on November 15th at 8:05 a.m.? In that field next to the house, aren't you? Inductive reasoning. You see a pattern there, you're going to be there to capitalize on it. Okay? Deductive reasoning is making decisions based on statements. Information you're given. Okay? You're an investigator for the police force. You go to a scene, you take notes on things you see. Okay? You make deductive reasoning, you deduce from one statement to another statement to another statement. You interview people. Okay? That's deductive reasoning. We're going to be talking about deductive reasoning. The law of detachment and the law of syllogism helps us use deductive reasoning. I only mentioned inductive reasoning because it's covered in Chapter 1 and we're not doing Chapter 1. And I wanted you to understand that there is such a thing as inductive reasoning. Okay? Law of detachment says if P then Q is true, then given P you can conclude Q. We have already done that. Okay? We said if everybody gets an A on Unit 2 test, then what? I'll buy more donuts, right?
You said you buy them. You said,
Yeah, I didn't actually say I'd bring them in, but I will. If everybody gets an A on Unit 2 test, I'll bring in more donuts. For you, not just for me. Okay? So there's our statement. So the day after the test, I have them all graded, and you all get together and you say, hey, I got an A, I got an A, I got an A. You discover everybody in the room's got an A. What do you expect is going to happen the next day?
We get donuts.
You're going to get donuts. That's law of detachment. If P represents getting an A on a test, and Q represents me bringing in donuts, and you discover that P happened, then that means you're going to get donuts. Paul?
What if someone gets an A minus? Does that still count as an A?
What if somebody gets an A minus? Well, that's a different story. Technically, that's an A. Okay, I can live with that. So if everybody gets an A or A minus, then we'll have donuts the next day. I might bring 10 donuts and we all have to cut off a little piece, but I'm just kidding. I'll spend the big bucks just for you guys.
Oh, hot dog.
You realize if every class had all A's, how much that would cost me?
Yeah.
Yeah, $80 at least.
Just go to Western after 10, you give them like 50 cents.
Oh, are they?
Yeah, after 10.
Oh, I gotta check that out. But do you think they'd have 80 of them there after 10?
No, you
Maybe I could collect a few days in a row.
I'd eat 'em.
They'd be good, then, wouldn't they?
Yeah.
Amelia's up here going, no. All right, move on. Law of syllogism. In an older book we used to teach from, we called this a law of transitivity. And when you learn the transitive property, you'll understand why they call it law of transitivity. Because it looks very much like the transitive property. This says, if P then Q is, and then Q then R are true statements, then if later you're given P happen, then you can conclude that R is going to happen. Okay? Copy it down. I know it seems like, let's see, German language. I don't think, do we have any people in here who can speak German? Seems like some foreign language anyway, doesn't it? All this P and Q talk. Okay? Well, you know it's important you always mind your P's and Q's, right? Now it's even more important. Pretty good, huh, neat Nick?
Oh, yeah.
Yeah. Nick, you know how you catch a unique deer?
No scope it.
No, unique up on it. You know how you catch a tame deer?
Why eat it carrots?
The tame way, unique up on it. Pretty funny, huh? That's a real neat slapper.
360 no slopes.
Okay. Do you know what you call a no-eye deer?
I have no idea.
Yeah, I just blew that one. Sorry, I really messed that one up. I meant to say, do you know what you call a deer with no eyes? And you say,
We always
I have no idea either. All right, moving on. Anybody not finished copying this down? Okay, let's apply it. What conclusion can be made from the following statements? Should write the question down so you know what we're doing here. What conclusion can be made from the following statements? I'm going to pause this while you copy this down, and then we'll talk. Go ahead and copy down the rest of these statements. Okay, first of all, let's just read through this, the three statements. If an animal is a red wolf, then its scientific name is Canis rufus. If an animal is named Canis rufus, then it is endangered. Johnny has a red wolf for a pet. Okay? Right, let's go back one step here. If we look at the law of syllogism, it says, if P then Q, if Q then R, then then given P, we can conclude R. Okay? So in this statement right here, what observations do you have about that? What do you notice? I'm not asking for any deep meanings, just what do you notice?
That P equals R.
What's that?
That P equals R.
P equals R?
That is R.
Okay, so you're saying that it's not really equals, it implies, right? Whoops, here. But that's okay. That's true. What else do you notice? Even less involved than that. Even more simpler than that. Catherine? Q would equal both, meaning, again, the word equal probably isn't accurate, but I love your observation. Q is in both statements, isn't it? That's exactly, Catherine, what I wanted you to notice. That Q is in both statements. We have a Q here, and we have a Q here. Okay? Q is in both. That's important to notice because when I go back to here, in these two statements, what do I see is in both? What's that? Canis rufus. If an animal is a red wolf, then its scientific name is Canis rufus. If an animal is named Canis rufus, then it's endangered. So what we're saying is this is Q. So being Canis rufus is Q. Okay, don't bail on me yet. We're almost done with this one. When Q was second in the statement, what was first? P. Let's go back to here. When Q is second, then the first one is red wolf. That's going to be P. And then when Q was first in the statement, what was second? R. And so when Q is first, then R is second. And so law of syllogism says if P then Q is true, and if Q then R is true, then P implies R. So what is this? Johnny has a red wolf for a pet. Is that P?
No.
Well, what was P? Red wolf, right? This is red wolf, so this is P. So what do we conclude? R, which means what? Means that Johnny's pet is endangered. Johnny's pet is endangered. Okay? All right, we are out of time, so we'll finish these tomorrow. I'll go ahead and post what we've done, and then we'll finish tomorrow. So just to wrap up the law of syllogism in this question, the statement could say, if an animal is an endangered, if the animal is a red wolf, then it is endangered. And so our conclusion, Johnny's pet is endangered, is because we were told that Johnny has a red wolf for a pet. And so our conclusion, we would write Johnny's pet is endangered. But it comes from this statement here. If an animal is a red wolf, then it is endangered. What conclusion can be made from the following statements? If n is a prime number greater than 2, then n squared is odd. The second statement is 9 squared is odd. And pause while you copy that down and we'll talk about it. This question is a little bit tricky because 9 squared is odd looks like this, which is the conclusion of this conditional. If n is a prime number greater than 2, then n squared is odd. And so the question is designed to make you think about it as if 9 squared is odd, then 9 is a prime number greater than 2. Unfortunately, that would be the converse. That would be the converse of the original conditional. The original conditional is true, but is the converse true? If n squared is an odd number, then does that mean n is a prime number greater than 2? Okay, remember prime numbers are 2, 3, 5, 7, 11, 13, and so on. Remember, the definition of a prime number has exactly 2 factors. So the factors of 2 are 1 and 2. The factors of 3 are 1 and 3. The factors of 5 are 1 and 5. The number 1 is not prime because its factors are 1 and 1, and that's the same number, so it really only has 1 factor. So in this case, as we look at this, we have to go back and say, is 9 a prime number? And the answer is no, 9 is not. So it's not, the converse is not a true statement. And remember, we learned earlier that just because the original conditional was true doesn't mean that the converse is true. So what conclusion can be made from the following statements? None. We do not have enough information. Okay? We do not have enough information. If n is a prime number greater than 2, then n squared is odd. The only way we could make this conclusion is if we were given the p part of this conditional. This is the r, this is the p. N is a prime number greater than 2. Q, p and q. Q is n squared is odd, and 9 squared is odd is q. So remember, the law of detachment says, from this previous page, law of detachment says if p then q is true, then given p we can conclude q. And we go back to this, we're not given p, we're given q here. So no conclusion can be made, not enough information. But the desire you will have will be to say the converse is true. And remember, that's not always true. Okay? So, next week, Monday, we will work on lesson homework 1 through 31 odds, including 16, 18, and 20. I should say in addition with 16, 18, and 20. All right? Have a great weekend.